Hello IED students. This video is about multi-view drawings for activity 1.2.3. So the main lesson objective. So first of all, you're going to learn what a multi-view drawing is and its purpose. And second, you're going to discern the layout of a multi-view drawing. And just as a reminder, when you're filling out your guided notes, be sure to write down anything that appears in blue in your guided notes. Anything that is of additional information that you would like to include on your guided note page, there is a gray box for you to put that information in. So again, the white box is for any blue text, and the gray box is for any additional information you think is important. So what is the purpose of a multi-view drawing? So we've started with isometric drawings, and an isometric drawing is a three-dimensional drawing, and it's a quick way to convey an idea. But the downside is that it doesn't provide accurate information about the true shape and size of an object. A multi-view drawing, however, it's also called an orthographic projection. These types of drawings provide precise details about an object. They also provide an accurate size and shape. And these drawings are used to manufacture or build the object. So when you're actually trying to pick a side in a multi-view drawing includes a series of two-dimensional lines called graphic models. And so each line represents a view of the object through the line of sight that is orthogonal or perpendicular to the face of the object. The corners and the edges of the object are projected onto an imaginary plane that is parallel to the face of the object. So in this drawing right here, you can see that the plane is located right here. So we've taken like a sheet of glass and we've put it in front of our object. Notice that that each object corner and visible edge from the line of sight is included in the orthographic projection. And so the resulting line drawing is called an orthographic projection. So if we project these points out, you'll notice that they make the corners of the object. And so that we simply connect those points to create the line and then create the object. So then we'd actually flip this around and look at it straight, and then we would be able to see the true size and shape of that object. So for the drawing views, a multi-view drawing typically includes a top view, a front view, and also a right side view. In addition to these three views, we also have an isometric view of the object, or a three-dimensional object. Sometimes, though, you will need additional orthographic projections, and other views are included when necessary to fully detail an object, as you will see later in the course. So basically what that means is sometimes objects require more than these top, front, and right side views to convey all the information. But typically we want to include those three plus the isometric. It's also possible, however, that you may only need two views. You might just need a front view and top view, or a front view and a right side view. And as we're looking at it from our line of sight, these arrows kind of indicate the direction that we would be viewing it from. And so that's how we actually establish the front, top, and right side of the object. So the alignment of our views, here we have the front view, top view, bottom, right side, left side, and rear. So if we take an actual object that's drawn flat or orthogonal, let's use this shape for an example. We have to have our base view. And so orthographic projections are usually oriented and aligned so that the front view is the base view. Other orthographic projections are aligned vertically and horizontally from the front view. If you visualize looking at the front of the three-dimensional object, the right side view represents the object as it would appear if viewed from the side to your right. And the top view represents the object as if it was viewed from above. So these drawings can be a little bit tricky. It's hard to actually visualize these objects and take them from a three-dimensional shape and try to flatten things out, but it's something that you would actually improve on the more you do it. So what's some of the criteria for determining a front view? So it's really the same rules that we used before in our isometric views. So the face of an object chosen as the front view is selected before a multi-view sketch or drawing is created. So as we learned earlier in this lesson, there are guidelines to help you choose the best front view. So again, it's the most profiled shape. It's the natural position of the shape. It's also including the longest dimension if possible. And there's a new rule as well that we'll talk about more later, and that's the least amount of hidden lines. And so the front view you choose will dictate the orientation of the isometric view as well as the orthographic projection shown as the front view on a multi-view drawing. That does it for this video. If you have any questions, be sure to ask.